Um, okay. This is our assignment, data structure assignment, and we are picking question 5. Our question is, for the following code, segment 1, 2, and 3, draw a sequence or trace diagram to show the insertion of each node into the linked list. Each trace diagram should show the insertion of node in sequence from the first node right up to the last node. So you can see here we have our code. We have our code from here until here. So in our code, we have a struct node. We have initialized variables, integer data, and also node object, pointer next, and also node object, pointer ptr, pointer temp, and pointer back. So we have a main body here, 1, 2, and 3. We will go through the main body in our answer. So let us proceed. So the first part, we gonna solve this code. Our objective is to translate this code to diagram form of linked list. This is the objective of our question. So ptr equal new node, ptr data should be 4, ptr next should be now, back is ptr, which means we have created a new node of ptr and insert ptr new node, insert data but with 4, insert data 4, and the next should be now. Yes, the next is now, that's correct. And then ptr back equal to ptr, which means that ptr address is assigned to back, so back should have the same address as ptr. So we've put back in the ptr node together. So here we finish our question, segment 1. So now segment 2, initialize integer x, x should be 0, is x lesser than 7, x loop. In the loop we have new node called temp data should be s plus 5, temp next is now, back next should be our temp, and back equal to temp. So in our first loop, we do this, we create a temp is new node, create a new node temp, and put our data x plus 5 into our temp, which means that first x is 0. Here you can see in our first loop x is 0, 0 plus 5, 0 plus 5 should be also 5, so we put 5 in our temp here. So then we point our node towards now, then we do this, back next should be temp. Our back is actually the previous node we have here, ptr or back. So remember this node, and then we should put the ptr back to pointing toward temp, because back next should be temp. So back next is temp. And then lastly, we assign the address of temp to back. So as I mentioned, the back should have the same address as temp. So finish our first loop, I go to the second loop here. So in second loop, s is 1, and then it's the same. We create a new node, we assign s plus 5, next is now, back next is temp, and back equal to temp. So same step, we as 1 plus 5 is 6, we put our 6 in our temp, the temp we created here, and then point it towards now. Then we have a same step. This is our previous we have this linked list, remember this linked list, and we are now point this the front of the back to temp, back to temp. So back is pointing to our new temp is 6 here, new 6 here, and the back is the temp, the back, yes, the back is same address as temp. So second loop finish, and the third is also the same step. So I just gonna go through what is the data insert, because I think you have already know what's going on. 2 plus second loop, third loop, 2 plus 2. 2 plus 5 is 7. 7 we put in our temp, temp put in our front, and also back is assigned to temp. Then we proceed again. The for loop is 3. 3 plus 5 add. We add it in temp, and also also back assigned to temp. And the 7 should be pointing towards add. And proceed. The fifth loop is 4 plus 5 equal to 9. We put 9 into our temp. The temp is the new loop. The back should be the back, and data 8 should pointing towards the temp, and then the back should go to temp. It's the same. 5 plus 5, 10. Same procedure, and also until 6. Why until 6? Until step we're gonna stop here. This also same step, and we put 11 as our temp linked to 11, and then the back going to our temp. But why we stop here? Because remember in our code, when the condition x is lesser than 7, yes, if the x indeed lesser than 7 in 6 here, but if we put it as next loop is 7, the condition will be wrong. So the 6 should be our last loop. Okay, so until here, this is the final diagram of our second segment. So here is our third segment. Third segment, the code is temp equal to ptr, cout list of data, space. While the data is lesser than 11, we print out the data of temp times 3, and temp should be equal to temp next. So let me expand in diagram. We have this whole linked list as we got from our previous segment, and then we do the temp equal to ptr. So ptr should go to the position. Temp should go to the position of ptr. Sorry. So our temp here go to the position of ptr here. Then our step. So we check. Then we check. While the data of temp is lesser than 11, we print out the data of temp times 3, and then temp should equal to the next of temp. Then okay, we check, is the data less than 11? Yes, 4 is less than 11. So we see out our data here, and then we move our temp to the next of our temp. So what you mean by move temp to next of temp is pretty simple. Our initial temp is at here, the next of temp should be at the node which has data 5. So we move here to here, temp from 4 to data 5. Okay, so finish our first loop, and then the second one we also check in the node with a data 5. We check the data 5 is also lesser than 11. Remember, lesser than 11. So we print out the data 5 times 3, the data times 3 equal to 15. So we have the data 15 here. Okay, then we proceed to our step. Temp should be equal to the next of temp, so we move temp to 6 next of temp. Okay, now another loop. Check again, 6 is less than 11 times 3, 18 again, and temp equal to next of temp, 6 move to 7. We have this data here, 12, 15, 18, and then 7, we check again, 7 indeed lesser than 11, 7 times 3 equal to 21, and move the temp to the next of temp. Also same for 8 times 3, 24 here, and then the temp moves to the next of temp here. 9 check, 9 times 3, 27, and then we move 10 to the next of 10, 10, the not 10 here, and then we move to 10, 10 times 3 equal to 13, and yeah, finish. We have finished our loop. Why we didn't go for the 11? And I remind you again, our condition should be lesser than 11 here, lesser than 11. If we equal or more than 11, our condition should be false. If false, the program terminate. Let me show you here. We move our temp from the node here to the next node, which data 11. So temp data should be 11 now. So temp cannot more than more than or equal to 11. So the whole program stop. And lastly, we will get ourselves the output, final output here. List of data 12, 15, 18, 21, 24, 37, 30. So thank you very much for watching. I will include the work file below if you want to have details on how to do this question. Feel free to check the link. Thank you.